Hello everyone. Welcome to the Gate Engineering online learning classes. In this video, we will discuss about the convolution sum. First, we will see how we can represent the discrete time signal using impulse response. Any discrete time signal xn can be viewed as a linear combination of time shifted impulse. Here we can see that xn is the input signal which is represented by summation of k is equal to minus infinity to infinity xk delta n minus k. Xk is the magnitude value at impulse n is equal to k, and delta n minus k is representing the impulse location. We have discussed about this in details in the last video. You can go through that video. The link of that video is given in the description box. Now, here T is our system that is transforming the input signal to the output signal. Here we assume input signal is the impulse signal, that is the delta n, and impulse function. When we are giving any impulse signal to the trans system, we will get output is hn, that is nothing but the impulse response. Hn is the impulse response when input is the impulse signal. So hn is the impulse response when input is impulse signal. Now we can write yn, which is our output, that is nothing but the t of x of n, where xn is our input, t is our system, and we are getting the output. When we are transforming any input signal to the system, we will get yn. Now xn is given in terms of the impulse function in this equation A. From equation A, we can substitute the xn in terms of the impulse signal. Summation of k is equal to minus infinity to infinity xk delta n minus k, where xk is the amplitude of the signal at instance k. Now we will check if the system is linear, how we can represent this signal or this function in terms of the linear property. We know linear systems satisfy the property of the additivity and scaling property. If we write t a x1 plus b x2, we can write a t x1 plus b t x2. This is the linear property which is satisfying the homogeneity and additivity property. So according to this property, we can write this signal as summation of k is equal to minus infinity to infinity xk. Xa will work as xk is like this, the constant at time instance k, and t delta n minus k. So we can write yn is equal to summation of k is equal to minus infinity to infinity xk t delta n minus k using linear property. Now if we talk about the time invariant property, if t delta n is hn, we can write when input signal is the impulse function, we will get the impulse response in the output. Similarly, if we use the shifted impulse signal in the input, we will get the shifted impulse response in the output. So t delta n minus k can be written as hn minus k, that is the shifted impulse response of the shifted input signal. So according to this property, we can write t delta n minus k as h of n minus k. So this expression can be written as yn is equal to summation of k is equal to minus infinity to infinity xk hn minus k, where xn is our input signal and hn is our system. If we convolve both of them, we will get the yn, and this is the convolution sum representation. Now, here we have seen that the system is linear and time invariant, then the convolution sum is satisfied for the LTI system. Convolution sum is suitable for the LTI system, linear time invariant system. That can be represented by summation of k equal to minus infinity to infinity xk hn minus k, and can be written as xn convolution of hn. This operator is nothing but the convolution operator. Xn is the input and hn is our impulse response of the LTI system, and star is the convolution operator. The convolution sum is helpful to find out the output value at any time instant, at some specific time. Let's see, if we want to compute the output y at time instance n naught, so we can write yn naught, which can be written as summation of k is equal to minus infinity to infinity xk hn naught minus k. Now we will solve one problem on the convolution sum. Here we have given the input signal xn, and the impulse response is that hn. Input signal is xn, which is 312, and hn is the 321. Now we want to convolve both of them, xn convolution of hn. So this is the property or definition of the convolution sum that can be written as xn convolution hn. Now this signal xn is defined for n is equal to 0, n is equal to 1, and n is equal to 2. Similarly, Hn is defined for n equal to 0, n equal to 1, and n is equal to 2. So, if we substitute the value of k from minus infinity to infinity in this expression, we'll get this kind of the expression. But here we are considering only k from 0 to 2 because x minus 1, x minus 2 are 0 and x3 and x4 are also 0. So here we'll get finite value for x0, x1 and x2. If we expand it more, we'll write x3 hn minus 3, but in our case x3 is 0, that's why we don't need to write here. Now yn is x0 hn plus x1 hn minus 1 plus x2 hn minus 2. So we'll substitute value of n is equal to 0, n is equal to 1, n is equal to 2, and so on to find out the value of output at some time instance n. Length of the convolution will be length of x plus length of h minus 1. Here we can see that length of x is 3, or 3 indexes are present in this x, and length of h is also 3. So length of y will be 3 plus 3, 6 minus 1 will be 5. So in this case, we'll get length of system response will be 5. What is the meaning of length here? Number of samples. Here number of samples are 3. Here number of samples are 3. So length of x is 3, length of s is 3. So we'll get length of y will be 3 plus 3 minus 1, that will be 5. So we'll get 5 samples in the output for this particular problem. Now yn is x0 h1, y0 is yn is equal to x0 hn plus x1 hn minus 1 plus x2 hn minus 2. Now we'll compute n is equal to 0. We'll compute for n equal to 0, y0 will be x0 h0 plus x1 h minus 1 plus x2 h minus 2. Here we'll substitute n is equal to 0. So h0, h minus 1 we'll get from here, h minus 2 we'll get from here. And in this case, h is defined for n equal to 0, for n equal to 1 and n equal to 2. So this term will be 0 due to h minus 2 is 0. This term will also be 0 due to h minus 1 is 0. So we'll get x0 into h0, x0 is 3 and h0 is also 3, we'll get 9. Similarly, we'll substitute value for n equal to 1 and we'll get x0 h1 plus x1 h0 plus x2 h minus 1 when we are substituting n equal to 1 here. And in this case, x0 h1 are finite value given in the question, x1 h0 are also finite, but here h minus 1 is 0 in this case. So we'll get x0 h1 plus x1 h0. In this case, x0 is 3, h1 is 2, so we'll write 3 into 2, and x1 is 1 and h0 is 3, so we'll write 1 into 3. So 3 into 2 plus 1 into 3 will get 9, and so on. We'll compute y2, y3, y4 and y5 also. So here we are getting y0, y1, y2, y3 and y4. If we compute y5, we'll get x0. If we compute y5, we'll get x0 h5, x1 h4 and x2 h3, and h3 h4 h5 are 0, so we'll get 0 for n equal to 5. So here we are getting yn is equal to 9, 9, 11, 5 and 2. Now this is the method for the conventional way to solve the problem in university exam, but for the gate exam you can solve by using shortcut trick or matrix method. Here you need to draw a matrix like this. Write the value for xn, p, 1 and 2. Write one side 3, 2 and 1. Now multiply this element 3 with all the element of x. So multiplying 3 into 3 will get 9. If we multiply 3 into 1 we'll get 3. If we multiply 3 into 2 we'll get 6. Now we multiply this 2 in all the 3 elements. So we'll get 3 into 2 is 6, 2 into 1 will be 2 and 2 into 2 is 4. Now we'll multiply 1 with 3, 1, 2. We'll get 3, 1 and 2. This is a shortcut trick. You can solve the problem within a minute or 2 minutes by using this trick. Now draw the diagonal line in this way. from left bottom to right top. So here, this element is corresponding to y0 because this is for n equal to 0, this is for n equal to 1, and this is for n equal to 2. And similarly, this value for of h for n equal to 0, for n equal to 1, and for n equal to 2. Here we are seeing that this 9 is coming from x0 and h0, so this will be the value for y0. Y0 will be 9 here. Now, between this box, we'll add 6 and 3, we'll get another next value, that is 9. We will add 3 to 6. 3 plus 2 is 5, 5 plus 6 is 11, we'll get 11. Similarly, we'll add 1 plus 4, we'll get 5, and last element is 2. So this is what we are getting: 9, 9, 11, 5, and 2 is the value for y. 9, 9, 11, 5, and 2 is the value for y. We can write in this way: 9, 9, 11, 5, 2. And first value is for n equal to 0, this for n equal to 1, so it is value of y1, 11 is the value for y2, 5 is the value of y3, and 2 is the value for y4. So here we are getting 5 elements starting from 0 ending at 4. And similarly, we can match the results from yn by using previous method: 9, 9, 11, 5, and 2. So what you can do, just you draw the matrix and multiply element with the other row and take the diagonal and add the elements, and you will get the value for the output y. In the next video, we will solve some more problem on the convolution using shortcut trick as well. Thank you for watching this video.